Welcome back to Python for Economics. Today we will start with section 3, that is assignment operator. See, we have already used equal sign to assign value. Python also provides assignment operators that update an existing variable. The main assignment operator are equal to sign, plus equal to, minus equal to, pointer equal to, or we can say asterisk equal to, forward slash equal to. Okay, so equal to is to assign, plus equal to is to add and assign, then minus equal to is to subtract and assign, and asterisk equal to is to multiply and assign, whereas the forward slash equal to is to divide and assign. So let us see a simple government debit example. Let's say government underscore debit is a variable equals to 1000. So what is happening? This is storing the initial value within this specific variable. Okay, now suppose there is an additional borrowing of 120. So how we can write it? Now we have initially assigned 1000 to government debit variable, and what we are doing is we are just writing plus equal to 120. So this means what? The government debit is equal to government debit plus 120. Okay, so ultimately this is going to be what? 1120. Okay, so let's execute this using a print function, and if you see, there is a second example. It says government underscore debit equals minus equals to 50. Okay, now using print function again, what we are doing is how it is going to work. Government debit is equal to government debit minus 50. Okay, and if you see, we are getting the result as addition, and here it is performing the subtraction operation. Okay, so now see this government underscore debit plus equal to 120 is nothing but what? It is equivalent to government debit plus 120. Okay, please keep this in mind. With this, let's move to the next section, that is operator precedence. See, whenever expression contains multiple operator, Python follows a specific order. This is known as a operator precedence. So we can say simplified order is just like your Bodemas rule. Like first we'll go with the parenthesis, second is exponent, third is like multiplication, division, floor division, and modulus, fourth is addition, and fifth is comparison, and lastly it is known as a logical operator. Okay, now say let us compare two expressions in front of us. First is result underscore without underscore parenthesis equals to 100 plus 20 pointer 5. Okay, so what will happen? Python will perform multiplication first. So what will happen? 20 multiplied by 5, ultimately this will be what? 100. Okay, then what will happen? Python will add 100 to that 100. Okay, and ultimate result will be what? It will be 200. Okay, now let's consider the second example. Result underscore parenthesis is equal to 100 plus 20. Again, it is both things are kept inside a parenthesis, pointer 5. Now what will happen? Parenthesis forces Python to add 100 and 20 first, and the result becomes 120, that is then multiplied by 5. Okay, so ultimately what is the result? Over here we are going to get 600. Okay, now we are going to just execute it and display the result. So if you see, first we are getting 200, and at second instance we are getting 600. Okay, so the output are different because the order of operation is completely different. In economic formulas, incorrect parenthesis can produce incorrect result. So even when the code runs without an error, this is especially important in the percentage calculation. Okay, now let's look at the next instance, that is percentage change formula. See, the standard percentage change formula is new value minus the old value divided by the old value and multiplied by 100. Okay, now what this means, see, in Python, old value, let's say the variable you consider old underscore value is equal to 200, new underscore value variable is equal to 230. Now what we do is we write percentage change is equal to, in parenthesis we are writing, again we are creating one more parenthesis bracket, new underscore value minus old underscore value divided by old value. Okay, and then pointer 100. So notice this parenthesis around the new value and old value. Okay, so subtraction must occur before the division precedence, right? Okay, so ultimately what will happen? We are going to display the result using the print function using the f string. So over here, once you execute the cell, you will see that we are getting the result as what? 15%. So this means what? The value increase from 200 to 230 and representing what? 15% increase within the scenario. Okay. Let's move to the next point, that is section 5, that is GDP growth. See, GDP growth can calculate it using the same percentage change formula. So let us illustrate over here. See, at first, let's take a variable previous underscore GDP is equal to 3200, then current underscore GDP is equal to 3500. Okay. Now let's calculate the growth rate. Now for this, what we are doing is we are taking a variable GDP underscore growth underscore rate is equal to, then again we are giving out the parenthesis. Okay, inside that parenthesis there is a sub parenthesis which says what? Current underscore GDP minus previous GDP. Okay, and then we are just multiplying it by dividing by previous GDP and then pointer 100. So once we execute the cell, okay, so you are going to get roughly around what? 9.38%. So see, the positive value indicate what? It is a growth. Okay, whereas the negative value indicate what? It's a contraction. So and 0 indicate what? There is a no change at all. However, the values must be comparable to each other. Okay, so we should not calculate the growth between nominal GDP and real GDP, annual GDP and let's say the quarterly GDP, different currencies, or the value that is measured with a different price base. So the formula may be mathematically correct, but incompatible data would make the result economically invalid also. Okay, so let's look at the next aspect, that is negative percentage change. See, let's decline that there is a variable previous output is equal to 500, then there is a current output equal to 460. Okay, and then we are computing the output change equal to, in parentheses we are writing in sub parentheses current output minus previous output. Okay, and then dividing it by the previous output multiplied by 100. So once we execute this using the print function, see, we are going to get what? The percentage minus percent 8%. Okay, now the negative sign indicates what? The output is getting declined. So do not remove the negative sign because it contains important economic meaning also. Okay, with this, let's move to the next example. Okay, so the standard value equals to 0. Okay, see, the standard percentage change formula cannot be used when the previous value is 0. Okay, so let's consider that there is a variable previous value is equal to 0 and then there is a variable current value equal to 50. Okay, so the formula would require what? Division by 0. Okay, so ultimately what will happen if I just execute this? It will produce like a give me output. But let's say if I am not giving it the specific instances, so ultimately what will happen? It will give me 0 division error. Okay, so therefore we keep the calculation commented in a different aspect. So but let's say if I am just removing this and printing out this stuff, you will see that we are getting an error known as what? 0 division error. Okay, so to avoid that, what I am doing is currently we'll be looking at different kinds of error too, but right now I'm just printing it as it is just to provide you the output. Okay, so instead of displaying a clear message, what we are doing is we are printing the print change is undefined when the previous value is considered to be 0. So mathematically, the standard percentage change is pretty much undefined when the denominator is 0. Okay, then let's look at the next example, that is labor market calculation. See, we will now apply operators to labor market indicators. Okay, how? See, the first calculation is unemployment rate. In this, first is unemployment. Here we are talking about what? The unemployment formula, which says what? The unemployed person divided by the labor force multiplied by 100. Okay, so this creates a value. Value of what? So let's say we have unemployed people 35,000, then we have a labor force 5,20,000. Okay, now we have to calculate the rate. So for which we are taking a new variable, that is unemployment rate is equal to unemployed people divided by the labor force pointer 100. So ultimately it is going to display the result using what? So we are going to use the F string. We are going to print the banner as it is. Okay, then with this we are going to we are going to call curly bracket in which we are going to call the variable name with 0.2f. Now this 0.2f means what? It is nothing but pointer, the decimal values up to 2 floating point values only. Okay, so once we execute the cell, okay, you will find that the result is approximately 6.73%. Now the most important point is the denominator. See, the denominator over here is labor force. Okay, so it is not the total population, the working age population, or the employed population. So using the wrong denominator would ultimately produce what? It will give you the wrong indicators. Okay, with this, let's move to the next point now. Let's talk about the labor force participation rate. See, labor force participation rate is what is calculated using the labor force divided by the working wage. Okay, and then multiplied by 100. So what we are doing is we are taking the variable, we are assigning the values, and we are trying to process that a new variable again with some kind of values. Ultimately, we are just printing it, and we are getting a certain result, that is 65%. Now 65% over here means what? The working age population is included in the labor force in a simplified example. See, remember that labor force definition may differ across data set and institution. So always verify age range, reference period, employment status, and the survey methodology. Okay, so this is how it works in different scenarios. With this, let's move to the next point, that is real wage growth. See, we will not calculate the real wage growth. So the common approximation is what? The real wage growth is approximately equals to the nominal wage growth minus the inflation. So what we are going to do? We are going to call the variables by assigning some kind of values to them. Again, a new variable assigning a value to them. With this, what we are going to do? We are going to calculate the approximate percentage of this. Okay, so approximate real growth we can say. So with this, we are going to display the result using the f string, and yes, we are getting the result as what? 2.70. Okay, so this is how the wage calculation get processed. So exact real wage growth is like a more like exact formula, like 1 plus nominal growth divided by plus inflation minus 1 divided by or multiplied by 100. Okay, so this is how the different kinds of processing works. Now with this, let's move to the next point, that is comparison operator. See, arithmetic operator calculates the different values. Okay, comparison operator basically compares the value. So comparison result is either true or false. So the main comparison operator are what? Greater than, less than, greater than equal to, less than equal to, and not equal to. So ultimately, let's compare an inflation rate with a reference rate. So for this, I am taking a small example. See, we have a variable inflation underscore rate is equal to 6.2, and we have another variable reference underscore rate equals to 4.0. So now let me just execute the all comparisons. So if you see, where it talks about inflation rate is greater than reference rate, okay, means what? 6.2 is greater than 4.0. Is it correct? Answer is true, right? So yes, we are getting true as a result. Second is 6.2 is less than 4. Is it correct? I hope not. Okay, so it is a false answer. With this, the next is what? It says 6.2 is equal to 4. So now we can easily understand that this is not at all, LHS is not at all equal to RHS. Ultimately, we are going to get the false result. But yes, it says inflation is not equal to reference rate, means what? 6.2 is not equal to 4. Okay, that's correct. Yes, right? So it's a true value. Okay, so this is how we go process the different comparison operator. With this, let's go check the economic threshold analysis. See, we can store result of comparison in a variable. Means what? For example, right now we have a variable unemployment underscore rate 8.5. Then we have a second variable slitted underscore threshold equals to 8. So above underscore threshold is equal to what? Employment rate greater than slitted threshold. So is it true or false? First let's check. It says 8.5 greater than 8. The answer is correct. Okay, so as the answer is correct, it is going to display the result like the above threshold is what? It is nothing but the values are above the unemployment threshold, and the value will be completely true. Okay, so it is see, it is not being presented as an official economic classification. Let me just tell you, it is just a economic interpretation in Python that we are making. Okay, so let's move to the next one, that is assignment versus equality. See, a very common beginner mistake is confusing equal to sign with double equal to. Okay, so see, when we say a equal to sign, it assigns a value whereas the double equal to sign compares the two value. Okay, so over here what we are doing is we are assigning 4 to this target underscore inflation, whereas if you talk about the observed inflation equal to target inflation, here what we are doing, we are performing what? We are performing a comparison between LHS equal to RHS. Okay, now with this let's move to the next one, that is logical operator. See, logical operator combine or modify the condition. So there are three logical operators: and, or, and not. Okay, so the and operator turns the true only when both the conditions are completely correct, right? So let's take an example. We have a variable GDP underscore growth equals to minus 1.5, then there is a unemployment underscore rate equals to 9.0. Okay, now we define a new variable, that is economic underscore stress equal to GDP underscore growth less than 0 and unemployment underscore rate greater than 8. So let's check the condition now. See, the first condition check whether the GDP growth is negative or not. Is it negative? The answer is true. Okay, the second condition checks the unemployment is above 8 or not. The answer is true. Okay, so true and true. Okay, so AND gate says what, whenever both the conditions are true, the answer is going to be printed true. Okay, so ultimately we are going to print the result using what? Using the print function we are calling f string. In that f string we are passing a double quote. Okay, in that we are going to pass the banner, then we are going to pass the f string variable. So ultimately once we execute it, the answer is what? The economic stress is really available. Okay, so it prints what? True as a condition. The next operator is OR operator. See, the OR operator returns true when at least one of the condition is true. Okay, so now what we are doing is we are processing the stuff, the OR operator, at least when the one of the conditions true. So now we will create a warning condition is equal to an inflation rate is greater than 6 or unemployment rate is greater than 8. So the inflation is above 6, so the first condition is going to be what? Completely true. Second condition is what? Unemployment is greater than 8, so it is not correct, right? So unemployment is not above it, so second condition is completely going to be false. So because at least one condition is true, the result is going to be get true. Okay, so let's check it whether it is going to get printed true or false. Yes, it says what? The answer is completely true. Okay, then there is something known as a not operator. See, not operator reverses the boolean value. Okay, means what? For example, if we say recession is equal to false, so we are declaring that variable as a false variable. So what we are doing is now we will write economy not in recession is equal to not recession. So ultimately what do you think, what will get printed? True or false? Whenever we say not, so it will provide us the negation condition, the opposite condition. So what we are going to do, we are going to just print it out, and let's say it is going to print us and give us output as true. Okay, so this is how the different operator work in different scenarios and it get processed in all the different cases. Okay, so that's all from my side for today. Thank you.